Hey there! In today's video, we continue the mini-series I started last time about rebuilding the heart of my smart home. So today we will talk a bit more about hardware, because last time I only mentioned it, and after taking a look on the hardware, we will talk more about the next steps that I've done with the software part. So if you're interested, keep on watching, and if you're new to the channel, let me introduce myself. My name is László Marcel, and this channel deals with home automation, home networking, and occasionally with related stuff like DIY electronics and even a little bit of 3D printing. Anyway, let's continue with today's topic. Okay, so what you see here, I think it's safe to call a Frankenstein server. It's basically 4 Raspberry Pis and a low-powered mini ATX PC embedded in the same ATX PC case, driven by the same ATX power supply and networked together. So basically the ATX PC acts as a controller, a firewall, a Docker host, all the stuff that is running Proxmox. And with the 4-port gigabit Intel network card, it also connects those Raspberry Pis through itself to the house's network. So this is basically the heart of my smart home, at least the hardware part. If you are a returning visitor of the channel, you might remember that I made various experiments with Raspberry Pi clusters and different power supplies, and then I just came to the conclusion, okay, so I'm running this mini ITX thing, why I just can't drive everything from a single power supply that is stable enough, that is powerful enough, and spares me a lot of cables and whatnot, because all these things are inside now a single case. As you can see, it's basically passively cooled, I mean the devices themselves, but we have these two big coolers for the adequate airflow. And so the problem of cooling the Raspberry Pi 4s is pretty much solved. Also, the thing is that silent, and it's quite energy efficient. Talking about energy, powering the Raspberry Pis is, ridiculously simple. Basically, I'm just using these pretty much worthless cables I got with some old PC case, I don't know how many years ago, and they were sitting in a box. Now I just decided that, okay, I will cannibalize these and will turn them into connectors for the Raspberry Pi. So I just took a simple proto board, soldered some USB AA female connectors to it, and connected these Molex connectors. So now I can draw safely those 5 volts from the power supply and supply them to the Raspberry Pis via the micro USB and USB-C cables. You can power the Raspberry Pis via the GPIO, but on the GPIO side there's no regulator and no protection, so you can easily fry those. As you can see, the case is pretty large. I can put more stuff in here. Also, it has a good cable management, and in the back I can add like 3 full-size HDDs, 2 SSDs. There's one SSD connected right now that hosts Proxmox, and it is connected to that mini ITX machine, and also acts as a shared storage for the Raspberry Pis. So with this fast local network between the mini ITX machine and the Raspberry Pis, they just use Samba for a shared network storage. The trade-off for all the processing power, storage, and memory and all the networking stuff is that this rig pulls a little more power than I expected. So during boot it peaks at around 50-55 watts, and then during normal load it goes back to around 45-ish, and then when it's totally idle it's around 30. So first I wasn't really satisfied with it, but then I just realized that basically we're talking about 2 Raspberry Pi 4s, 2 Raspberry Pi 3 Model Bs or B+, and mini ITX machine, 2 coolers, an SSD. So yeah, it's not that much considering it all together. Also, I'm planning to lower the RPM of the fans, those coolers, because they are spinning at a high speed right now, higher than needed. I mean, the room is air conditioned, there's not really too much heat generated within the case, so I can spare some power too. Also, I had this idea, and I'm working on it, to be able to shut down the Raspberry Pis individually when not needed. For that, I will need just a control mechanism I can connect to the mini ITX machine, and some relays to cut power from the Raspberry Pis, and of course a mechanism for turning them off, I mean shutting down the operating system before pulling the plug on them. So with everything assembled, this little rig sits on my bench waiting for its final place and for its uninterruptible power supply, and while at it, it also controls my 3D printer. With the firewall in place, I don't have to worry about anybody trying to hack into the printers and burn the house down or something like that. So anyway, jokes aside, let's continue with the software part and let me show you what I've made, what I've done since the last time. So let's just start with the Proxmox host, the mini ITX machine you have just seen. So with minimal interruptions, it's been running 24/7 for 2 weeks now, and it does its job pretty well. So as you can see, the CPU is nearly running, I think around 15% or something like that, and the memory is a little more than halfway, no swap used at the moment, and now it's getting load. So there are these occasional spikes in the CPU usage, but those are more like background functions of the operating system, like checking for upgrades and whatnot, but not part of the long operation. So it's been running the firewall for the Raspberry Pis. It's running the Docker host with various software I get back to later, and yeah, it's been running Pi-hole with all the clients in the house, all the phones and Amazon Echo devices and PCs and you name it, connecting to that one. So it takes it quite well. And now, yeah, regarding software, I've also installed Heimdall on this machine, on the Docker host, because I really like this dashboard just to access all the stuff I'm running. And as you can see, there are different pieces of software. Not everything is running on this one. So for example, MB, as the home media server we are using, is not running on this one. Also, the home automation stuff is still running on the old server. So Home Assistant, EMQX, those are still running there. Tasmo Admin as well, which is for the Tasmoto devices. And yeah, but for example, Octoprint is already running on one of those Raspberry Pis behind the firewall, and Portainer, well, it's a special case. So next time I'll show you what I've done with Portainer, because it's pretty cool. Okay, so just let me open Portainer. One click, and here we go. And voila! As you can see, there are 3 different stacks, or 3 different servers to be honest. And because, yeah, I have Docker running on the Proxmox machine. Also, the 8 GB Raspberry Pi 4 is pretty much a Docker host as well. And yeah, this is the old server, still running some of the containers. And now I have a single interface managing all those. This is pretty neat, huh? So the trick behind this is using Portainer agent. Portainer agent, I think it's pretty much a hidden feature, or at least not many users are aware of it. I mean, I have quite a few friends who are using Portainer, but I think they never tried Portainer agent, which is a shame because it's a good feature of a Portainer. And yeah, I know, I'm still running an old version of Portainer. I just migrated my stuff here. I will upgrade later on because Portainer C has been on the net on the web for quite a while now, and I still haven't tried it. Shame on me, I know. What I really like about this configuration is that I don't have to touch Raspberry Pis anymore. I mean, I can just click here, go to this Raspberry Pi, run containers on it, and then go back, switch servers. This is pretty cool. Also, if I have to do some low-level access to the Raspberry Pis, and like connecting via SSH, I don't really have to move away from this web browser. And for that, Proxmox is my friend. So just let's take a look. Proxmox, here we go. This takes me to the main host. And because this is basically a closed network with the Raspberry Pis, I can just use IP-Fire from within Proxmox as a Bastion to connect to the Raspberry Pis. So those are really in a closed network, and all the ports that are opened up are just really the necessary ports. You cannot even connect them via SSH. Obviously Wi-Fi is disabled and stuff like that. So just let me show you something. I select the IP-Fire VM, and then it has a built-in console which I can connect to. And now I'm logging into IP-Fire. And from here I can log into the Raspberry Pis. Obviously, if I want to go more secure, I can set up a more sophisticated authentication for Proxmox, because now with this single login I can do a lot of trouble. However, this is restricted to my PC, so I really have nothing to fear of. And I have total control over this whole stack from within this single web browser window. Okay, I think this is what I wanted to show you today. And as you can see, I've made quite some advanced enhancements to the system, and as I've mentioned already, it's quite stable. So I'm now on its way to really start installing home automation stuff on it. So next time we're starting with Home Assistant, the MQTT broker, and stuff like that. If you enjoyed the series so far and haven't subscribed, consider subscribing, and yeah, hope to see you next time, next week, with the next installment of the series. Have a nice day. Bye. You're still here. That's good, because that means you kinda liked my video. If so, feel free to check out these other videos too. And if you're new to the channel, please consider subscribing. That helps me a lot. And yeah, if you click the bell button, you will get also notified about new videos.